Hello class, welcome to week 6 of Programming Logic with Python. So this video is going to kind of be a heavy video because we do have quite a bit to cover because there is quite a bit that comes with dictionaries and sets. But before we get into that, I do want to mention at the end of this video, I will be kind of talking to you guys like more of a one-on-one conversation about the end of the semester and what I want to offer you guys for the future. Past this course, like beyond this course, how I want to offer my help for you guys. So yeah, that'll be at the end of this video for like 10 minutes, so if you guys want to stick around for that. But let's kind of get started. Let's jump right into this because it's quite a bit that we have to cover. So a dictionary, we're going to start off with dictionaries. To create an empty dictionary, we use curly brackets. So we know a list uses square brackets, a tuple uses rounded parentheses, a dictionary uses square or curly brackets. So if we know that, the other important thing to know is that a dictionary doesn't just take in regular elements or values, it takes in pairs. So if you're going to write a dictionary with actual stuff inside of it, we have to pair them up. And we pair them up by using a colon to separate the key, which is on the left-hand side, with a value, which is on the right-hand side of the colon. So if we look at this example right here, we have key 1 colon Jeff, which is the value. And then we have key 2 colon Bob, and so forth. And we separate all of these pairs with commas. So at its most basic form, that is how we create a dictionary. Now, a dictionary cannot have multiples, duplicates. So if I have a key that's already 1, I can't have another key that's 1 as well. When that happens, that other key that was written after the fact replaces the original. So I originally wrote Jeff as my first entry inside of this dictionary, but then later on in this dictionary, at entry number 3, I wrote key 1 again. So because entry number 3 was written after the fact, that new duplicate replaces the old one. That's just how it is. Python will not give you an error. It will just replace it by itself without telling you. So do keep that in mind if you are creating a dictionary and you're like, oh, well, what happened to this value? That's what happened. So this other example, I'm just trying to show you that your key doesn't just have to be an integer data type as it is up here. We could have keys that are string data types, that are Boolean data types, or float. We can mix and match data types as we wish when it comes to dictionaries. They're very flexible in that form. So yeah, one more thing I did want to mention was dictionaries in the newest version of Python are ordered. In older versions, they were unordered, which means that if I had this dictionary list right, or not list, this dictionary right here, with entry number 1 being Jeff, entry number 2 being Bob, and so forth, with the old version of Python, every time I printed out this dictionary, Jeff might be first on one print, and then on the second print, Bob might be first. Like key 2 colon Bob might be the first entry. It will just switch every time because it was unordered before, but now it is ordered. So just something brief I wanted to mention. So let's move on to accessing elements inside of a dictionary. So we have a dictionary here that has 2 pairs. The first pair is name Jack, the second pair is age 26. So there's 2 ways of editing or accessing elements inside of a dictionary. The first way is something that might be familiar to you guys. It's very similar to how we would get index positions or how we would use index positions to grab elements inside of a list, but we don't really use index positions when it comes to dictionaries, just because dictionaries used to be unordered, and since they used to be unordered, using indexes really just didn't make sense because you never knew where certain entries inside of your dictionary were because it was always changing. So indexes were never really useful with dictionaries, and now that they are ordered, we still don't really use them. We really just use these 2 methods. So the first way of doing it is you would say the dictionary name, or the variable that's holding your dictionary. So I'm doing my print statement. I'm doing this all inside of a print statement. So I'm doing my dictionary square bracket. So you do have to use square brackets. So in that case, it is similar to the way we would kind of like use indexes, but we're not using indexes. So square bracket, and then inside of it, instead of putting that index number, we're putting the key that we want the value of. So if I put the key of name, I'm just telling Python, hey, for key name inside of this dictionary, give me the value associated with it. So the value it's going to give me is Jack. So for the second example, the second example is actually the other way of doing it. So instead, the second method actually uses a method, or the second way of doing it is actually using a method. And this method is called the get method. So this get method is very similar to the way we've used other methods before. So it's my dictionary period get, and then inside of it, inside of the get method, inside of its parentheses, we just put the name of the key that we want the value of. So it's very similar to this first example, but instead of just doing these square brackets, we're just doing period get and then open parenthesis. So two different ways of getting to the same place. The one major difference between these two ways of doing it comes with this example right here. So let me just comment on this. So what if we use the get method to try to reference a key that does not exist currently inside of our dictionary? So here we have the key of address, and both of these examples I'm trying to tell Python, hey, for the key of address, give me the value associated with it. Well, as you guys can tell up here, there is no key that's named address. So Python will handle this request differently for both of these methods, or for both of these ways of accessing elements. So if I were to use the get method to try to find the value associated with the key of address, what happens is Python will not error out the code execution. It will run the code without giving you any errors, and it will just simply tell you there is no value associated with this key. And it does that by just saying, just returning none. Now, for the second example, the one that kind of looks like how we would use indexes, what happens if I were to run this line of code is Python would say, okay, well, I'm going to search for the value of address, or the key value, or the key of address, and because I can't find it, instead of just telling you I can't find it by returning none, as the get method did, I'm gonna be really stubborn, and I'm just gonna error out your entire program. And I'm just gonna return, I'm not gonna allow you to output anything. I'm just gonna error it out and tell you the key of address doesn't exist. All because of that one thing. All because you tried to look for a key that doesn't exist in the dictionary. I'm going to error out everything. So in that way, that's kind of why I'm telling you, hey, probably use the get method, because the get method is a lot more user-friendly or coder-friendly than this old method. It's not old, but no, it is a little bit old. The get method is better. So I do suggest you guys use the get method. But basically, that's how you access elements inside of a dictionary. There's two different ways of doing it. So let's look at how to add or change elements in a dictionary. So kind of, once again, there are two ways of doing it. You'll kind of like get used to me saying this. And I just kind of realized that I deleted my dictionary. Yeah, I kind of need this. Okay. All right. So I want to retain the same dictionary that I was just working with, but now we're going to add or change elements inside of it. So we're not accessing anymore, we're adding or changing. So there's two ways of doing it. The first way might look familiar to you. Once again, we have the name of the dictionary, square bracket. So the same, it almost looks like the way we use indexes, but we're not using indexes. We're using keys. And inside of the square brackets, I just put the key that I want to reference in this case. So I'm saying for the key of age, assign it, because the equal sign is the assign operator, the value of 27. So by assigning it this new value, it actually replaces the old value that the key age had, which was 26. So if I were to print this out, which this line is trying to do, it would print out age, it would print out the whole dictionary, but age would have a new value of 27. That's all it's doing. I'm not going to run it just for the sake of time. I will run lines of code that I think are more complicated and it's better to see, but for this, I think it's pretty straightforward. So this, it's also doing the same thing. Well, actually, this is not actually doing the same thing. So remember in the previous example when I was trying to search for the key of address using this method of square brackets. Remember, Python was being stubborn and it just errored out everything. But in this case, I'm assigning this key of address a value of downtown. So what happens in this case, on this line right here, because I wrote it in this certain way, I'm telling Python, hey, for this key of address, I'm not just saying, hey, search for this. I'm saying, hey, for this key of address, assign it a value. And I'm telling it the value is downtown. Because I gave Python not only the key and the value, or not just the key, but also the value, because I'm giving it both sides of the equation of the pair, Python says, okay, if you give me both of them, fine, I'll add both of them to the dictionary, and that's perfectly valid. And that's essentially what's happening here. So if I were to print this out, I will actually run that. So let's kind of run that piece of code. So yeah, we get downtown, we get the key of address and the value of downtown added to the list. Not the list, sorry, the dictionary. Because it's a dictionary because it's curly brackets. So now this last line of code right here. So this last line of code is the other way of adding or changing elements inside of our dictionary. And this other way, obviously, if you guys have been paying attention, is using the method, or is using a specific method, and this specific method is the update method. So same syntax as a typical method. We do the name of the dictionary, period, update, open parenthesis, and then inside of it, instead of just writing like certain values, we have to tell Python, hey, what we're updating here is a dictionary, and to tell Python that we're updating a dictionary, we do have to include the curly brackets. So that's why I included the curly bracket here and here, and then inside of it, inside of those curly brackets, we just write it as if we were writing a singular pair. So the key of age, colon, and then whatever value I want age to now have. And then just by writing that, Python will update that key with that new value. So once again, I do recommend using the method, the update method, to update or add elements to your dictionary. It's probably the cleaner way, and it's probably the more less confusing way of doing all of this. So that's pretty much it for that. So let's move on to removing elements from a dictionary. So there's a bunch of ways to remove an element from a dictionary. The first way is using the pop method. The pop method. The pop method, it's a little bit different here because the pop method, obviously, before we either used pop without an argument or pop with an index position, but remember, we cannot use index positions with dictionaries. So instead of using an index position as our argument, we can use, as we've been using, the key as our argument. So you might be thinking, oh, this 4 is an index position 4. Well, it's not. It's actually the key 4. Because if we look at our dictionary up here, we have a key of 4 that has a value of 16 associated with it. That's the pair. So here, when I say pop 4, I'm saying pop for whatever values associated with the key of 4. So when I'm printing out pop4, this is actually printing out 16 because it's doing squares, which is the variable that holds the dictionary, and I'm saying pop, and then give me the value associated with the key of 4. And that's why it's going to print out the value associated with the key of 4. Now, if I were to print out squares, which I'm doing on the second line of code, it's going to print out this dictionary without 4:16 because 4:16 got popped. It got removed from the dictionary. So yeah, I'm not going to print that out because it's pretty straightforward. So let's move on to pop item. So pop item is another way of doing it. So pop item essentially removes the last entry or last element in our dictionary. Now, when dictionaries used to be unordered in previous versions of Python, pop item was more of a random generator sort of way of eliminating things, because remember, things were unordered, so every time you ran pop item, it would just pop a random thing out of your list. Didn't necessarily pop the last entry, so like it wouldn't always pop 525. Sometimes it could pop, or it could pop 1 1. It could pop 4 3, or not 4 3, 3 9. It would pop random things because everything would get moved around randomly. But now that dictionaries are ordered, you do kind of know what it's going to pop. It's always going to pop 525. So it's just another way of removing elements from a list. You don't necessarily have to use it. You could just use the pop, regular pop method. It's really up to you. So let's move on. So there is a, well, there is another way of, so say there's another way of removing elements from a dictionary, the clear method. So the clear method is essentially what it says it's going to do. It clears out the entire dictionary. So if I have a dictionary with all this stuff inside of it, if I just wanted to start from scratch because I messed up uh, and I don't want to necessarily use the pop method to delete the one mess up, maybe I messed up a lot of times. I just want a clean slate. The clear method's perfect for that. You just do the variable that's storing the dictionary, period, clear, no arguments inside of it. It just clears out everything. It leaves you an empty dictionary. So that's perfect. So that's the clear method. And then if you want to delete everything, the variable and the dictionary that's stored inside of that variable, just do delete and then the variable name, squares, and it just deletes everything. So you could reinitialize squares later on and associate it something else, maybe a list. I don't know. So yeah, very simple, very straightforward. So methods. So we have been using methods quite a bit thus far, but we're going to take it one step further. I do want to introduce you, I do have other methods down here, so the items method, the values method, the keys method. I don't have examples for those, but those are methods that you might want to maybe become familiar with just for the future, and maybe even for your homework. So do kind of like on your own time, maybe like look for examples for those methods. Those methods are not complicated by any means. That's why I didn't put examples, because I was like, it'll become too repetitive if I go over each method. But I do want to include them because at least like let you know that they exist, because they are useful when dealing with dictionaries. But the method I do want to kind of go over here is the from keys method. So this from keys method is really cool because it allows you to take a dictionary that only has keys inside of it, and then a regular variable that has a value associated with it, and then combine them together. So I think that's pretty cool. Remember I did tell you that you couldn't have a dictionary, like remember when we were searching the key of, I forget what it was. uh, I don't remember. But remember, I think I told you that you can't have a key without a value. Um, but here, I just have a bunch of keys and Python's not returning an error. Well, the reason it's not returning an error is because all these keys have no values. But the moment I give one of these keys a value, you're going to see that it returns an error. So :2. So yeah, it doesn't like it. It's giving me an underline saying you're not allowed to assign a value to this key because all of the other keys don't have values. So yeah, just keep that in mind. So you could have a dictionary with only keys. It's kind of weird to do that. The only reason you would do that is if you're going to implement this key from keys method to it. So I'm going to show you what this from keys method is. So we have a dictionary with only keys right here. So that's perfectly valid. And then we have this regular variable that has a value associated with it, vowel, and it's a string. Okay, well, I'm saying vowels, which is a brand new variable. It's just like, yeah, brand new variable called vowels, and I'm equating it um, the syntax for the from keys method. So the syntax from the from keys method is always going to be dictionary right here. So dict period from keys. So this keyword right here is just telling Python, hey, um, create a dictionary. That's what we're creating right here. Period from keys, and then from keys takes two arguments. The first argument is the key, the collection of keys that we're going to be dealing with. So that collection of keys is coming from right here. And then whatever the second argument that it takes is the value. This value can be a singular value as it is here of just vowel. So what happens when Python reads this entire line is it says, okay, well, he gave me a bunch of keys, A, E, I, O, U, right? And then he only gave me one value. So what I'm gonna do here is I'm gonna create a new dictionary, and I'm going to populate it with all these keys, and then I'm going to assign each of these keys the value of vowel. They're all going to have the same value of vowel. So it's going to be A colon vowel, comma, E colon vowel, comma, I colon vowel, and so forth. And I can even show you, let me just comment out the rest of this. All right. Yep. So here, what ended up happening was it ended up so it's being randomized, which is funny because it wasn't randomizing it before. Okay, interesting. Well, I need to check what version of Python I'm running. I'll check that later on. It might be the version of Python I'm running it on, but it's treating this dictionary as an unordered dictionary, which, like I said, was the older version. That's how it was in the older versions of Python. But with the newer version of Python, dictionaries are supposed to be ordered. So that's why it's a little bit confusing. But it did what I told you it was going to do. It took all those keys and it associated the value of vowel to each of them. So that's essentially what it does. Let's see, what is this? So here I have a list of 1, 2, 4, and then, oh no, I have a variable of keys 2, which is assigned a list of 1, 2, 4. Then I have numbers. Okay, I think I see what's happening here. Dictionary from keys, keys. And then if I run this, let's see what happens. Oh, I have to comment out all this. Okay, none. Okay. 1, 2, 3, 4. Wait a second. Keys 2. Oh, you know what? It's because I didn't put keys 2. I was like, where's keys 2 being implemented here? Oh, okay, yeah, okay. So that's what was, yeah, that's my fault. So what happened here was I just kind of created, I originally had a list, right? So if we look at this example right again, so here I was originally working with a dictionary that had a bunch of keys inside of it, but here I'm actually working with a list. So I have keys 2 and I'm assigning a list which has values of 1, 2, and 4. And then I'm saying, I'm creating a whole nother variable called numbers. I'm assigning it dictionary. So I'm saying, Python, create a dictionary out of this list, and then take all of those values that I gave you of 1, 2, and 4 and make those the keys, right? So make those the keys for my new dictionary, but I'm not giving you a value to associate with to all those keys. So what's going to happen is it's just Python's going to create a dictionary of only keys. So it's going to look very similar to this, but those keys are just going to be 1, 2, and 4. So that's pretty much what happened here. Um, Oh yeah, because I didn't include a value in the from keys argument or the from keys method, because this was supposed to take two arguments, but because I didn't include the second argument, by default it just inputs none. So I forgot to mention that. So yeah, that's the from keys method. So you could start with a dictionary of only keys, or you could start with a list of just regular values and turn that into a dictionary. Um, I just want to show you that. I thought that was pretty cool. So that's it from the from keys method. Membership. So what if you wanted to know if a certain uh, key existed inside of a dictionary, right? So here, let's remove this. 49 in new dictionary. All right, so not 49. Let's do 100. Okay, so, oh no, we could do 49. Let's do 49. So we have a dictionary right here. I called it new dictionary, and I gave it a bunch of pairs. So 1, 1, 3, 9, 5, 25, 7, 49, 9, 81. So if I wanted to check the membership of certain keys inside of my dictionary, and I could only do this with keys, you cannot do it with values. You could only check key membership. You cannot check value membership. I would do the key in question, which in this first example is 1, and I would use the keyword of in, and then whatever dictionary I want to traverse through. So here I'm just saying, is the key 1, is that present inside of the dictionary of new dictionary? And Python's just going to return, well, actually, I'll just show you what it returns. Whoops. So I have to comment out all of this. Okay. So it's going to return a Boolean. So it's going to say, okay, yeah, for that first statement, it was true. There is a key 1 inside of the dictionary of new dictionary. Okay, well, what about for the second example? Is 2 a key that it currently exists inside of the dictionary of new dictionary? Well, yeah, I do believe, is there 2? Oh, no, no, no. So that's not what I wrote, sorry. I said is 2 not in the new dictionary. So there shouldn't be a key called 2 inside of my dictionary. And Python says true, or I do believe they say true. Yeah, they say true. So yeah, they're basically confirming what I'm speculating, that there is no key called number 2 inside of my dictionary. Now for this third example, I'm saying, well, is there a key of 49 inside of my dictionary? And Python's going to return false. And I could run it again just so you guys can see it. So yeah, now Python, there is a value of 49 present in my dictionary, but Python doesn't search for values when it comes to membership. Python only can search for keys. So that's why Python said false, because there is no key of 49, but there is a value, but Python doesn't care about the value. So I just want to show you that too, because I thought that was pretty cool too. Built-in functions. So this is really the last thing as far as dictionaries go. So I do need to actually get my dictionary back. Um, I deleted it. Okay. All right. So built-in functions, there's really only 2 built-in functions that we really need to worry about, and that is length and sorted. So we have seen these before, but I do want to kind of remind you that they do exist and that we can use them for dictionaries. So length obviously is going to tell us how many pairs we have inside of our dictionary. So here we have 1, 2, 3, 4, 5. So it should return 5. Yep. So it basically tells us how many pairs we have inside of our dictionary. And for sorted, it's just going to sort the keys. It's not going to sort the values. So we had a key of 1, we had a key of 3, 5, 7, and 9. So this was more useful when dictionaries were unordered. But now that they're ordered with the newest version of Python, it still can be useful, but it's not as useful as it once was. But if you're using a older version of Python, then sorted probably will be your best friend. So yeah, those are two built-in functions that we can use with dictionaries. So I just want to show you guys that. So that's pretty much it for dictionaries. So we are done with that part of the lesson. So now let's move on to sets. So sets are the other organized, or not organized, because as you can see, they're unordered. Another way of collecting data inside of something. So sets, like dictionaries, are enclosed inside of curly brackets. So you might be thinking, okay, well, how do I differentiate a set from a dictionary? Well, a set doesn't use pairs. It's just singular values that we put inside of sets. So that's really the key giveaway. So it's similar to a list in a tuple in that form, where it's just singular values, but where it separates itself is it's with curly brackets. Now, you might be thinking, okay, well, that's easy enough, makes sense. Well, how do I create an empty set? Wouldn't that just be a dictionary? You're right, it would be. So if I were to just do my set one equals this, if you remember from earlier on in this video, that's how you create an empty dictionary. That is not how you create an empty set. Because we use the same enclosure for a set and a dictionary, that's where confusion could come from. The way you create an empty set is actually this way. So it would be, where was it? Here. Okay. So this line right here, I do have a variable called a, or it could be my set, it doesn't matter, and I equated the function, the built-in function of set. So set, open parenthesis, close parenthesis, no arguments inside of it. And by doing this, Python's creating an empty set for you. And I can double check that by doing type A. So type will just tell me what type of what data type is currently being placed inside of that variable, the variable of A. But we're going to get to that. I just want to quickly mention that because I'm sure that's a question that might have popped into your head. The way we create a populated set is very straightforward. Variable name my set, equate it, curly brackets, and then whatever values. Now, with a set, we can do multiple data types inside of it. We can mix and match as we would like. So a set is unordered. So this hasn't changed with the new version of Python. It is still unordered. So if I were to have a set with values of 1, 2, 3, when I ran that code, it doesn't mean that it's going to print out 1, 2, 3. It could print out 2, 3, 1. It could print out 3, 1, 2. It'll change every time because it's unordered, meaning Python won't sustain the order in which I originally placed those elements. So in that way, sets are unindexable, meaning you can't really use indexes with sets because it defeats the purpose. If you call index position 1, it's index position 1, the value associated with index position 1 will always change. So it defeats the purpose of an index because you're essentially randomly putting your hand inside of a basket and pulling out different things every time. So in that way, it's unindexable. So the element itself inside of a set, so an element of 2 cannot be changed. So you might be thinking, okay, well, why do you say a set itself is mutable? Well, I'll actually get to that. So later on, I'll get to that. But for now, just know that the element itself cannot be changed, but the set in its totality can be changed. Um, so let's see. So if I were to print this out, so yeah, I'll show you this much. Let's print this out. Okay, so originally it was 1, 2, 3, right? So it printed out 1, 2, 1, 2, 3. So we just got lucky on that first line. That second line was my other set, which was 1.0, hello, and then a tuple of 1, 2, 3. So if you notice on that second line, it's 1.0, the tuple, and then the hello. So that tuple and then the hello got their positions changed because it was random. Okay, well, let's run this code again. Okay, we got lucky again. This is just very unlucky. Okay. Is this just not going to change? Oh, you know what? If I do... Really? Okay, then. I'm not going to fight luck. Just know that it's unordered. As why it's continually printing out 1, 2, 3 is weird, beyond me. Just know it's unordered. It should print. Should have printed out random numbers. It should have been 2, 3, 1. Should have been 3, 2, 1, and so forth. It just wasn't. I'm not going to fight it for sake of time. We'll move on. So we know that this right here is how we would create a empty dictionary, and this right here is how we would create an empty set, right? Because yeah, I told you that. So let's print this out really quick, just so that you guys can see and know that I am not lying to you. So yeah, I had two print statements there. The first was taking the type of that empty A, so this right here. So this line right here, type, and then type is the function, the built-in function, and I'm saying for the variable A, give me the data type that's for whatever value stored inside of it. So I'm telling you that this is an empty dictionary because an empty dictionary is just open and close curly brackets. But this right here, I'm reassigning the value of A to set open close parenthesis, which is how you would initialize a empty set. So now when I do type A, it should give me data type set. So when I run this, that's why you should see class dictionary and then class set. And class just means that that goes on to next week. We're going to be covering that, so don't worry too much about that. But yeah, that just confirms how to create an empty set in dictionary. So yeah, a lot to cover. Okay, so modifying sets. Oh god. Okay, so I do need my set back. Okay, so we'll keep this. Okay. So remember when I told you a element is unmutable, meaning you can't change the element, but you could change the set itself, right? Okay. Well, here under modifying sets, I am saying that I want to add a value of 2 to my set. So what do you think is going to happen here if I were to print this out? If I were to print out my set. Okay. So it added 2, but it looks the same as it originally did. Why is that? Well, a set, actually, I don't even think I mentioned this. A set, like a dictionary, does not take duplicates. So because I added 2, which currently already existed inside of my original set, it didn't add it to the end of the set. It just said, oh, there's already an entry for 2, so I'm just not going to add another 2. But what happens if I added 4? Okay, now because there was no 4 originally in the original set, it added 4 to that set. So that's great. So there is another way we can add elements to our set, and that's using the update method. So the update method is very similar to how we've seen other methods be utilized. It's the name of the variable that's holding the set, period update, and then open parenthesis, square brackets. So we are using square brackets here. Why? Not because you need to use square brackets, but because you can add collections like a list to a set. So in this case, I'm updating my original set of 1, 2, 3, and I'm saying add a list as the 4th element in my set. And that list contains the elements of 2, 3, 4, 5. So when I add this, you might be saying, well, okay, well, you added 2, 3, 4, 5. to the original set of 1, 2, 3, and that added 4. So why aren't they showing? Well, because sets don't like duplicates. So even though those sets were enclosed inside of a list, Python will still say, oh, there's duplicates inside of that list. I'm not adding them. I'm just going to add 5 because that's the only new value being added to this set. So that's what happened there. Um, so yeah, um, pretty cool in my opinion. But that's pretty much it. Let's move on to removing elements. So notice that we're not really touching existing elements inside of our set. We're adding stuff, and in that way, the set is mutable because we can add, we can remove, but we can't really change an existing value of an element. So like if I added 2, I can't change 2 to something else. It stays 2. Um, Hopefully that makes sense. So removing elements, there's a bunch of ways we can remove elements. The two kind of similar ways to remove an element is the discard and remove methods. They essentially do the same thing. So remember, once again, we are not referencing index positions here. We are referencing the element itself. So here, when I say my set 3 period discard, and then I pass the argument of 4, that 4 is not an index position. It's actually the element inside of the set. So I'm referencing this directly. So I'm saying if you find an element inside of this set that is number 4, just remove it. So that's what's happening here. Because remember, sets are unorganized, so there's no point in referencing an index position. And then same thing with remove. They really both do the same thing, but I just wanted to show you. Um, Pop. So pop will, this is actually, so if I had to do this, okay. So pop is literally a random removal. As remember when dictionaries, when I said dictionaries used to, when you use the pop method, it used to randomly delete just like a random thing. With sets, it actually is just removing a random thing from the end of your dictionary, or the end of your set. So we have a set of 1, 3, 4, 5, but when Python pops something from here, it might pop 5, it might pop 1, it might pop 3. It's really random because every time it prints it out, it's popping a random thing that just happens to be printed out at the end of that set. So why you would use pop, I don't know, maybe it's not the best way of going about things. Clear. So clear is actually pretty useful because it does what it did with dictionaries. So you have a bunch of values inside of your set. You just use the clear method. It empties your entire set without removing the set itself. So it just empties it out and it leaves you with an empty set. So that's pretty useful there. So that's pretty much it for removing elements. Let's move on to membership. And we're pretty much close to the end of this video, which is great because we're at like 43 minutes. And like I said at the beginning of the video, I did want to get to the one-on-one kind of talking that I did want to mention. So membership. So membership is very similar to the membership from a dictionary. So we have a variable called mySet. We're equating it a set. Remember, this is the set function. That's what I'm doing right here, the set function. And then I'm saying this set only really has one entry inside of it, and that's the string of apple. Okay, well, when I'm trying to check membership here, because my set only has one string inside of it, it's really just going to take that string and it's going to break it down by letters. So when I do membership and I do print and I say, is the letter A inside of the set of my set, it's going to look at this entire word and break it down. It's going to be like A, P, P, L, E. And it's going to say, okay, well, actually, let me print this out for you. So let's do print my sets. Okay. Yeah. Okay. I don't know why it's randomizing it now and it didn't randomize it before. It's It's a headache. It randomized Apple. So it took the argument of Apple and it broke it down into individual letters when it created the set. So it didn't just create like a set of like my set equals this. It didn't create that. No. It created essentially a whoops, P, P, so forth, Apple. And it randomized it because it's unordered, a set's unordered. So that's essentially what it did. And then when I'm printing it out, or not printing it out, when I'm printing out it, if I'm checking to see if values exist inside of my set, I would do a singular value, which is A, which is a valid value. And I'm saying, is A inside of my set? It is. So Python's going to return true. It's going to return a Boolean. And then when I say, is P not inside of my set, we know P exists twice inside of my set, but actually it's not going to print out P twice. It's actually just going to print it out once because you can't have duplicates. And actually I could just confirm that right here, just so that I know that I'm not going crazy. So let's run this. Oh, what happened here? Print my sets. Oh, okay. Yeah, there's only a singular P. Okay. I just want to make sure I'm sane. Okay. So close this. So yeah, there's only going to be one P even though there's duplicates right here. When Python does take that argument and puts it inside of a set, it's going to say, okay, well, we can't have duplicates, so I'm just going to only include one P. So when I do this print statement right here where it says, is P not inside of my set, Python's going to say, well, that's false because P does exist inside of your set even though it only exists once. So that's why it's going to return the Boolean of false. So that's membership. Let's move on to built-in functions. So built-in functions is the very last thing I wanted to mention as far as sets go. So there's a bunch of built-in functions that are available to you with sets, but the two or the three that I thought were the most important were the max, min, and sum functions. So to utilize them, it's very simple, very straightforward. We have a variable called numbers. We equated it a set of a bunch of values. And now I want to get the biggest number that exists inside of that collection. And remember, that collection is random. It's always going to be random. And I don't really know what's inside of it because every time I print it out, like say this was like a set of 1,000 numbers. If I were to print it out, it would just take up my whole screen and it'd be very difficult to read. If I just wanted to know what the biggest number out of those 1,000 numbers were, I would just do max and then whatever variable holds my dictionary. So that's what's happening here. I'm creating a new variable called new num, and I'm equating it, the function of max, and the argument I'm passing is the variable that's holding my, not dictionary, holding my set. So when I print this out, what actually gets printed out is the biggest number. So it should print out 34. So let's just double check. Oh, I need to print it out. Sorry. So let's print this out again. So yeah, it printed out 34, perfect. So the min function works very similar to the max function, same thing, but instead of taking the biggest number of that collection, it's taking the lowest number and it's going to print it out for you. So in this line right here, I'm just assigning the lowest number to a brand new variable of new num2, and then here I'm printing it out. So it should print out -4, but we could just double check that right here. So I'm going to run this, and it printed out 34. And it also printed out 34, which is the highest number, and then -4, which is the lowest number. I'm sorry about that. So the last built-in function I want to show you was the sum function, and the sum function does what it essentially says it's going to do. It takes all of those numbers, and it gets the sum of all those numbers. So I can just show you what that does. 77, great. And that's pretty much it. I'm a little bit exhausted because it was like a lot to cover, and I was trying to do it like really quick so that the video wasn't too long. But that's pretty much it. So that's dictionaries and that's sets. They are a little bit confusing because they're more involved as far as like writing them correctly in Python. But they are relatively restrictive when compared to a list and even a tuple. They are a bit more restricting, but they do serve their purposes. A dictionary giving you the ability to pair a key with a value is very useful when creating a collection of maybe employees and like you want to like employee numbers, like an employee name and an employee number. A dictionary is great for that. A set can be great for data that's not necessarily too important as far as like the order in which the data is saved, but maybe like you have like a bunch of numbers, like a bunch of maybe like not grades. Let's see, what can be important? Maybe like you have like student grades. So like you guys all have grades for all the assignments you do, and maybe I don't really care too much about the assignment the grade is associated with, but I just want to know the grade in general so that I can calculate it for your final grade. In that case, maybe I can store all of that inside of a set and then use the sum function to kind of do the math for me. Maybe it could be useful in that case. Maybe even the max and min. That way I can kind of get the class average. I don't know, something like that. I'm just thinking of examples where where a set can be useful, where a dictionary can be useful. They both serve its purposes, but their purposes are relatively unique. But that's pretty much it for that. So that's it for this week. So now let's kind of move into the second part of this video. So if you guys remember, I did promise you guys this video on Thursday or Friday of last week. But the video didn't come out on Thursday or Friday. As you guys know, it's coming out on Monday. The reasoning was because I was really on the fence as far as how I wanted to structure this video. Because we're kind of moving towards the end of the semester, next week being our essentially last week of real content of this course. Um, and all the progress you guys have done throughout this course, I really feel like you guys have progressed. Even though I don't see you guys, just like by your homeworks and by the questions you guys ask me and the way you guys are presenting your code when you do have questions, I can tell that you guys have progressed in your knowledge in Python. So I'm really proud that you guys have made that progress. But because you guys have made that progress, I've been on the fence as to whether or not I should increase the level of difficulty of the stuff that I'm presenting to you in this video. And what I mean by that is um, your textbook teaches you Python in a certain way. It teaches you essentially what I call and what most people call the data structures section of Python. And data structures just means syntax, basic syntax, a for loop, a conditional statement, so forth. That's all. That all falls under the umbrella of data structures. But there's another side of Python, and that other side is just as important. That other side is called algorithms. And algorithms is how a programmer, it's a tool that the programmer uses to solve complex programming problems. So yes, the programmer does need to have a solid foundation on how to write code in that programming language. But the programmer also needs the logic. And the logic is what solves the problem for them, or at least helps them solve the problem for them. And that logic is what we call algorithms. And what I've been thinking these past couple of days is, well, you guys have progressed so much, and I feel like you guys are ready to learn about algorithms. But obviously, it's not on the syllabus, and obviously, we're on a condensed schedule. So I was thinking, well, is it fair to introduce that topic to them? For some people, maybe. For some people, you guys might want, for some of you guys, you might want to learn about algorithms, but for others, you might be like, well, um, I already have enough on my plate. Like I'm working full time and I'm doing this, and this is like new, new, new content enough that I don't really need more difficult stuff on top of it. So I was really trying to take this all into account when deciding on whether or not I wanted to include algorithms in this video. And at the end of the day, I decided not to. But I did kind of like reach a compromise. And that compromise is I am going to try to appease both sides. So by appeasing both sides, I'm not including algorithms as a requirement for this course, or even including the topic in these videos. Um, but for those who are interested in algorithms and more advanced Python coding, I will be releasing videos after the semester finishes. So after week 7, just plan a week after week 7. So week 8, even though there's no week 8, I will be releasing the first algorithm video. And in that video, I will be going over at least one of the most commonly used algorithms that is used by programmers to solve complex programming problems. And I will be using Python as my foundational programming language to do so. One thing I should note is that these algorithms are kind of not specific to any programming language. They're just used across all of them. So learning algorithms once well is useful across like your journey in learning a bunch of programming languages because you don't have to relearn them really because they're just applied differently with the data structure base that I'm giving you guys right now. So hopefully I didn't confuse you there. So what you guys are learning right now, what you will learn up until the end of week 7 is all data structures. Algorithms is something completely different, but is needed to complete and to really just work in like programming jobs. So if for those who are interested in that, I will be posting those videos on YouTube a week after this semester ends. So the first video will be posted there, and it'll be available to you guys. Obviously, I won't be able to post the link on Blackboard, but if you guys are interested, just like save the URL to my YouTube video, maybe like on a notepad or something, just so that you have it and to go back to whenever you want. Or you could subscribe. It's either option. I'm not going to force you to subscribe. I want to offer you guys this resource essentially. The second thing is if you guys want more of a one-to-one kind of instruction on algorithms, I will be offering that for Tunxus. And so let me close Visual Studio because we don't need Visual Studio anymore. So let's go to Firefox. Firefox? Okay. So Firefox right here. Yeah, so let's do Tunxus course search. All right. So if you just Google Tunxus course search and then look for the one that says SSB-prod and then just click on it. And so you're going to be brought to this web page. So this web page, all you have to do is do select term, fall 2022, Tunxus, get courses, and then just scroll down. So we're going to scroll down all the way to the computer classes. And I'm showing you this because in one of these courses, I teach a couple courses. So I'll be teaching, I think, 6 courses this fall. So the point isn't to advertise my courses. If you want to register for my courses, great. If you don't, I won't feel offended. But the point is for those who want in-class instruction on algorithms, I will be teaching this one course. This will be the only course that will be touching on algorithms that I'll be teaching, and it's the Advanced Java Programming. So the Advanced Java Programming, I chose this course as the course that I'll be teaching advanced algorithms, or not advanced algorithms, but algorithms with, is because it's the quote-unquote advanced course. So there is a baseline course for Java, which I won't be teaching. That's another professor. But I will be teaching the advanced. So the advanced, um, I'll be going into this course with the perception that all of my students have at least, at base minimum, some coding background. So if you've taken this Python course and you want to take this advanced Java course, and Java is obviously another programming language, that's okay with me. So if you need that exception through Tunxus, obviously you would have to maybe shoot me an email. I'm not sure if there's prerequisites for this course, But regardless, if you're interested in this course, shoot me an email and we can kind of like sort through that. I can maybe talk with Tonxus and be like, oh, this student wants to take my course. And the reason I make that exception is because even though this is another programming language, um, the algorithms I'll be teaching you guys in this course can be applied to Python as well. It could be applied to Python, it could be applied to C++, and so forth, because the algorithms aren't programming language specific. So I do feel like it could be useful for you guys if you guys are interested in an in-class sort of style where um, I'll be teaching you algorithms. I won't be teaching you the basics here because you guys already have the basics. Um, I'll be teaching you algorithms, and I'll be teaching you, and I'll be giving you guys advanced programming problems for you to solve in class. So the class will be run slightly different than this class is, um, but I just wanted to offer it to those who are looking for more of a challenge, who are wanting to kind of like really refine their skills and really like put themselves out there. So that's what this course is for, the advanced Java programming, not the other one that I was highlighting. So this one, it has my name under it too, so advanced Java programming, and then my name's right there. So we'll be taught on Mondays. Yeah, only Mondays every week. The traditional style, so only in class. So if you're interested, it's there for you. Another class I will be teaching is the object-oriented using Python or using C++. So this class will be taught in a very similar fashion to this current Python class because I see this as an intro-level C++ class. Um, so I'm going to be teaching you the data structures of C++. I'll be teaching you how to create a for loop in C++ because it is different. The syntax is different. C++ and Python are not the same syntax. It's fairly different. But I'll be giving you a foundation with that course. So if you are looking to, maybe you're not looking for too much of an advanced course, so maybe not the Java course, but maybe you want to still expand your knowledge base, but with a different programming language, then maybe this course is great for you. So that course is also available. I will be teaching Python again in a similar fashion as this course, maybe with slight differences, but relatively the same. But you guys won't have to take it because you've already taken it. But yeah, I just wanted to offer this because I do get emails with students who are like, oh, well, I'm looking for like a more advanced coding course. So if that's what this is, that's what advanced Java will be this coming fall. So if you are looking for that advanced coding course, that's perfect for you. And it's really going to prepare you for the real world, where you're going to have these complex problems and you're going to have to use algorithms to solve them. So that's kind of what I've been debating on. That's why this video was delayed. I'm going back to that. Um, I didn't want to combine an intro level course with advanced topics. I kind of did because you guys are doing so well, but at the same time I said that's not fair for you. I'll separate them. For those who want a more organized, traditional style teaching environment, then I would recommend the advanced Java for advanced topics. If you want intro level, but for a new language, then the object-oriented programming using C++ is perfect. If you want something that's like something that you can kind of like watch videos and just like go at your own pace, then my YouTube videos where I will be introducing algorithms might be the thing for you. So that's three different options that I want to offer you guys, and you guys don't have to take them. I'm not forcing you to take my classes, but I just want to show you that these options are there for you, and obviously like the descriptions are not necessarily like I don't know if you click on this. I don't know what comes up. I think this is just for textbook. Yeah, it doesn't tell you much. So like that's why I kind of wanted to give you like an overview of how I'll be running my classes in the fall. So the object-oriented C++ will be run similar to this Python course, where I'll be introducing the programming language to you and giving you the basic data structures background, the foundation for the course, for the programming language. But this is more advanced. So the advanced Java will be more advanced. Um, yeah. I feel like I'm repeating myself now. But yeah, that's pretty much it. I was pondering, and that's where the delay came from. Uh, and I apologize for that. But I've sorted things out. I've kind of like, I was like, okay, I'm gonna put this here. I'm gonna do this. I'm gonna create these additional videos for you guys on my YouTube after the semester finishes, and that's how I'll kind of just like uh, help you guys because at the end of the day, um, I'm a professor and I'm a young professor. You guys know I'm young. I'm not too young. I always say I'm old, but I'm not super old. Um, so I was a student too, not too long ago, and I always enjoyed professors who really cared about their students. So when I became a professor, I told myself I was gonna do everything in my power to help my students. So that's kind of what I'm doing here. I want to reach out to you, and that's kind of why I created these YouTube videos every week, because I want to go beyond the textbook and kind of give you everything that's inside of my brain and put it on Visual Studio so you guys can see, um, and give you like my perspective on how things work. Um, so yeah, I don't know what I'm saying anymore. I'm rambling. The point is, I want you guys to succeed not just in the classroom but beyond the classroom. And uh, I've been using these past couple of days to kind of organize my thoughts on how best I can not only help you guys in this class that you guys are currently taking, but beyond that. For your next semester, or if you guys graduate, I don't know if any of you guys are going to graduate, then maybe the YouTube videos might be helpful for you since like you obviously don't want to pay for additional Tungus classes. So just giving you those options, giving you additional resources is kind of what I was trying to do. And that's what I've been pondering. And I feel like I've made the correct decisions where I'm not burdening the students who don't want that, because not all students want that, and that's perfectly fine. But for those who do, the options will be there for you. But yeah, I think that's really all I wanted to mention. Hopefully, well, if you've stuck around, great. Shoot me emails if you guys are interested in anything that I just said in the past 10 minutes. If you guys want me to cover certain algorithms for those videos after this class finishes, then by all means, I'll gladly cover them. And yeah, that's pretty much it. So I'll see you guys in week 7. So this video is going to go up today on Monday. It's about like, yeah, like midday on Monday right now. So I'll be posting this video today. The coding packet will also be going up today as well for week 6. Week 7's stuff, I'm not going to promise Thursday because every time I say Thursday, I'm not going to... Let's shoot for Friday. Yeah. I'll probably record it like maybe even tomorrow, but let's shoot for Friday at the latest. I keep on saying Thursday and Friday, and there's always something that comes up. But let's shoot for Friday for week 7's video. But yeah, that's pretty much it for this week's video. I did cover quite a bit, and I did try to go through it relatively quick to keep this video short. But yeah, I'll see you guys next week.